Okay, so we're going to be figuring out the connections between wavelength, frequency, and type of electromagnetic waves, and we're going to do this by doing some metric conversions and then also using our chart to make some approximations. So there are several units used to express wavelength to help identify the type of electromagnetic waves, including nanometers, micrometers, picometers, and such. The most common units for frequency are hertz and megahertz, like you have a frequency on the radio, okay? So if I'm looking at this chart, okay, we have our electromagnetic spectrum, gamma rays, X-rays, ultraviolet, visible, infrared, microwave, and radio. And the way that we're going to use this chart is by lining it up, okay? Similar to how we did spectra and stars and elements and lining up those emission spectra, we're going to do the same thing to approximate either the wavelength or the frequency. The next lesson we'll actually calculate it, but for now we're just going to identify the type of wave and then approximate either the wavelength or the frequency. And again, we're going to do that by lining it up. Okay, so I'm going to use a ruler to help line it up, but that's what we're going to do. So let's start with our example. Okay, we also have our common prefixes used in the metric system, and there is one I want us to add. So at the very bottom, I want you to write in pico. P-I-C-O. Its symbol is P. It's a whole bunch of zeros right here, okay? It's very small, but the part I want us to write in is the order of magnitude, 10 to the negative 12th. Okay, so I want you to add that in. And so pico is a very, very, very small unit, 10 to the negative 12th. And remember, a way that we can read this to help us use it in unit conversions is the symbol is what comes before the base unit. And so we can say 1 of whatever this is of our base unit is going to equal 1 times whatever the order of magnitude is of that base unit. Okay, so it's a way for us to use this chart. So again, we're going to say that 1 of whatever prefix we have of a base unit, so 1 megahertz equals 1 times 10 to the 6th hertz. So we're going to be using this chart the way that we've used it before, just to help us get that metric conversions, okay? All right, so let's go ahead and look at our example A. So A, what type of light has a wavelength of 2.07 times 10 to the negative 3rd meters? Okay, so on my actual paper, I'm going to write example, and we're going to solve A, okay? And what we're going to do here is we are going to use the chart, and we're going to try to figure out what type of electromagnetic wave this is, okay? So 2.07 times 10 to the negative 3rd meters. I'm going to find the meters. See, we have meters, centimeters, and nanometers. My meters, I'm going to go over to 10 to the negative 3rd. Okay, I'm matching up the the last part of that scientific notation because it's telling us the magnitude, right? So 10 to the negative 3rd. Now, this 2.07, I need to figure out where this is. Is this going to be to the left of the 10 to the negative 3rd or to the right of the 10 to the negative 3rd? And for that, I need to look at the scale, okay? So what this is really saying is 1 times 10 to the negative 3rd. This way is 1 times 10 to the negative 1st, and then this way is 1 times 10 to the negative 5th. Well, this way is getting smaller. To the left is getting smaller. To the right is getting bigger. Well, 2.07 is bigger than 1. So that means I'm looking at my chart to just to the right. 2.07 is to the, yes, just to the right. And so that would put me at a microwave. So for A, my answer is microwave, because I'm just to the right, because 2.07 is bigger than 1. So it's just to the right, which gets me that type of wave to be microwave. Okay? Because this is 10 to the negative second, 10 to the negative first, and so on. Okay, B. Now B, what is this wavelength in nanometers? Okay, so now I'm going to do a metric conversion where I have my given 2.07 times 10 to the negative third meters. And I'm going to do a metric conversion, and the way we set this up is dimensional analysis, the same way that we've done in chemistry, the same way that we've done earlier in this school year. It's just a dimensional analysis, okay? Where whatever we're given goes on the bottom, and whatever we want is on the top. So we're given meters, and we want nanometers. So what we're going to do then is look at our metric system chart. Nano is right here. It's a small unit. So I'm going to say, just like we had talked about earlier, 1 nanometer equals 1 times 10 to the negative 9th meters. So that is my conversion. That's my ratio. Okay, so again, it's a relationship. It's representing the same amount of physical space in terms of distance. It's the same physical space, okay? And so I can use them interchangeably. Just like I can say 2 bicycle tires for every 1 bicycle, or 1 bicycle has 2 bicycle tires. It's the same relationship, okay? So on my paper, I'm going to say that 1 nanometer equals 1 times 10 to the negative 9th meters. 1 nanometer equals 1 times 10 to the negative 9th meters. Okay? Now my units, meters and meters will cancel, which is good because I need nanometers. Now if we think back to dimensional analysis, this is just like fractions. The 2 numerators on the top, you multiply, and the denominator on the bottom, we're going to divide. Okay? All right, now let's put this in our calculator. Okay, now we're going to put this in our calculator. Okay, and we need to remind ourselves about how we do this in a calculator with scientific notation. So, I want everyone to put it in their calculator with me, okay? We need the muscle memory. 2.07. We don't want to type in times 10 to the, because a lot of times that gets us an extra order of magnitude. So we're going to use the EE button. So second, and then this x minus 1, it gets us this baby e. The little e means times 10 to the. It already means times 10 to the. You don't need to add a multiplication symbol. You don't need to add the little caret to indicate an exponent. All you need is the little e, okay? And then next I would type -3. Now note, this bottom button, this is the minus, or excuse me, the negative button. And this one is a subtraction button. So we want -3, okay? If you choose the minus one, it's like subtraction and you're gonna get an error signal, okay? So -3. So what I have typed in right here is this 2.7 times 10 to the negative third. That's what that means, okay? Times 1, we know that doesn't really do anything. Divided by, so I hit the divided by button. I'm just going to type it in to keep the format the same. 1 second e, which means times 10 to the -9. And again, the bottom button is negative, and the button on the right is minus. Okay? You might be tempted to use this little 10 to the x right here. That is inverse log. Don't use that button. Just use the e, and it makes it easier. Enter. okay, now you have this big old long number. Well, we could write all the zeros, but a lot of times students make mistakes because they're trying to count zeros. So we can turn this into scientific notation. Do you see right here the DRG? And above it is sci/eng, like engineering. You hit the second button, second, because I want to access the psi, DRG. The flow just means like your normal numbers, okay? We're going to arrow over to psi, meaning scientific notation, enter, and now your answer is in scientific notation. And it tells you it's in scientific notation because of the SCI right here. So then our answer is 2.07 times 10 to the 6th. What are the units? Nanometers. All we did right there was a metric conversion. These two are representing the same amount of physical space. Okay, it's just a metric conversion. All right, C. It's asking us for the approximate frequency. So again, the next lesson we're going to actually calculate it because we're going to use the speed of light using our wave speed equation. But today, to get us more comfortable with these things, we're just going to approximate using the chart. So before, we had said that we are just here to the right of the 10 to the negative 3. So I'm going to use my ruler and just say, okay, well, if I'm right here, then if I drop this down to where my frequency is, what number is that closest to? 10 to the 11th. So I'm going to approximate the frequency of this line to be 1 times 10 to the 11th or times 10 to the 11th hertz. It's an approximation, okay? Again, the reason why we're doing this today is just to get us comfortable talking about these things, and then tomorrow we're going to calculate it. So, C, the approximate frequency is 1 times 10 to the 11th hertz. Okay. In math, what is the symbol for approximately? Isn't it the little curve, right? The little wiggle. So I can also say approximately 10 to the 11th hertz. The symbol means approximately 10 to the 11th hertz. Okay? And we are just approximating. All right, let's look at number 1. Let's do number 1 now. I'm just going to slide my paper this way. Number 1. So it says, show your work units and box your answers. By work, I mean your setup. Okay? I don't need to see long division or long multiplication. I know your calculator can do that. So number 1, an X-ray has a wavelength of 0.85 nanometers. All right, that's what I'm given. What is this value in meters? And what is its approximate frequency? Okay, well, we're going to do kind of what we did for the example, right? So our wavelength of our X-ray is 0.85 nanometers. What is this value in meters? Okay, so for that, we need to do a metric conversion, okay, where we're going to convert nanometers into meters. So 0.85 nanometers. I'm going to set up my dimensional analysis train track the exact same way I did the example. But now I'm going to cancel nanometers on the bottom. And I want meters on the top. And then it's a metric conversion. Where if I look at my chart, it's the same thing. 1 nanometer equals 1 times 10 to the negative 9th meters. So I'm going to plug those values in to my railroad track, my dimensional analysis. 1 nanometer is 1 times 10 to the negative 9th meters. And I'm trying to follow the same structure every time, so that way we're consistent in our explanation. This relationship is interchangeable. 1 nanometer equals 1 times 10 to the negative 9th meters, and 1 times 10 to the negative 9th meters equals 1 nanometer. It's the same physical distance. So nanometer and nanometer cancel. And now we're going to multiply. Okay, so if you put this in your calculator, what do you get as the answer? 8.5 what? Times 10 to the negative 10th meters. Perfect. Okay, and real quick, to make sure and show that we know how to do this, 0.85 times 1. The second EE means times 10 to the negative 9 equals 8.5 times 10 to the negative 10. Perfect. The other part of that question says, what is its approximate frequency? Okay, so its approximate frequency is going to be something in hertz. So I'm going to go back up to my chart, and I'm going to find 0.85 nanometers. So nanometers, my chart right here. You could use meters too, because you just solved for meters. Nanometer here is 1. To the left is less than 1, and to the right is greater than 1. So 0.85 is less than 1. So it's just going to be just over here. Just over here somewhere. Okay, so if I drop this down, I'm going to end up with an approximate frequency somewhere over here. So you could say an approximate frequency of 10 to the 16th, or excuse me, 18th. You can say 10 to the 17th. It is an approximate frequency. You will not have an exact answer, and it's okay that it's an approximation. Okay, so I'm going to say, we're just going over here just a little bit, okay? I'm going to say this is closer to 10 to the 18th. So I'm going to say 10 to the 18th hertz is my approximate frequency. And again, it's an approximation. So this one, we're looking at the rest of these practice questions as doing a metric conversion, identifying the type of electromagnetic wave, and then either approximating the wavelength or the frequency. In our next lesson, we're going to use wave speed, the speed of light, Planck's constant, and energy to do the calculations to find the exact values.